Okay, in this video we're going to be going through 7F, which is power. So the real thing to remember for this unit is it's something we've gone over before. We've talked about power before, but we're going to be talking about specifically power as it relates to electricity. So first thing, remember that power is the rate at which energy is transferred in a given time. So you've seen this before. The formula power, P, is equal to the amount of work done, W, over the amount of time it takes to do. So again, that's a general definition of power. So power is work over time. This is always valid. What's new this section is electrical power. So it's power, electrical power is the rate at which electrical energy is transferred in a given time. So again, power can imply, lots of different energies are being transferred and how fast that's taking place. Electrical power is only how fast electrical energy is being transferred. So the formula for electrical power is a little bit different. So again, power, this formula is always valid, the generic formula, but for if you're dealing with electrical energy flowing, you could think about electrical power, P, and it's P for simplicity's sake instead of putting a little subscript. So again, electrical power P is equal to the current I times the voltage V. So that's how you could calculate electrical power. The unit for power, including electrical power, is going to be the watt. So W, right, this is review. So like if you see 5W, that's 5 watts. That's going to be a unit for power. 5W, 5 watts. Next couple things, a common unit for electrical energy. That we can use the joule, right? But another common one you'll see out in the world is the kilowatt hour. Kilowatt dash hour, and it's abbreviated kW times H. So the kilowatt hour is just another unit for energy, specifically electrical energy. So joules are valid always, but the kilowatt hour you'll see sometimes for electricity. And the conversion is 1 kilowatt hour is 3,600,000 joules. So 1 kilowatt hour is a very large amount of joules. Okay, so that's really it for no, it's not a whole lot of new concepts. So reminder of what power is, what electrical power is, what the units are, and then the unit kilowatt hours, which is a common unit for electrical power. So that's about it for concepts. Let's see a problem now. Here we go. So before I go through this problem, please take an attempt at it first. Okay, so we'll go through this. So it's asking, how long could you run a 100-watt light bulb for $1 worth of electricity? Assume that the light bulb is plugged into a 120-volt outlet and electricity costs 10 cents per kilowatt hour. So let's think about this. What are we looking for ultimately? So it's asking how long could you run the light bulb for. So it's really ultimately, we have a light bulb. Light bulb. Sure. Okay, that's a pretty bad light bulb. But either way, we have a light bulb. We're looking for how long we can run it for if we have $1. So we're looking for the time. We know that we have $1. We know that the power of the light bulb is 100 W, 100 watts. We know that the voltage is 120, or it's plugged into a 120 volt outlet. And we know the rate of electricity is going to be 10 cents per kilowatt hour. Kilowatt hour. So that's all the stuff we know. So we're looking for time, and how do we figure out time if we know these things? So if you skipped ahead, if you didn't attempt the problem first, and you were stuck, it might be a good point now to pause it and see if you can solve it from here with knowing that this is your unknown time and knowing that these are your knowns. So it might be a good idea to pause it to see if you can solve it from here if you were stuck before. Okay, so let's go forward. So we get to think about what's an equation. Really, if we're looking for time, we know the power, and we know dollars per. We know we have a dollar, and we know how much, 10 cents will buy us in terms of. We know that 10 cents will buy us 1 kilowatt hour. So remember, kilowatt hour is energy. So how can we relate energy, power, and time? Really is the idea. So one way we could do that is looking at the power formula in general. Power is equal to work over time. So we know what power is, the power of the light bulb. If we could figure out the work, then we could figure out what the time would be. So let's think about that. We know we have a dollar, $1, and we know that it costs 10 cents per kilowatt hour. So if we have $1, and each kilowatt hour is 10 cents, that means that we can buy 10 kilowatt hours worth of electricity. And again, a kilowatt hour is just a form of energy like joules. Same thing. So we can buy 10 kilowatt hours of electrical energy. So again, if we know we have 10 kilowatt hours of electrical energy, that's really the amount of work that's being transferred in a light bulb. So now we have work. So we could solve for time, but there's one thing, this is not in the standard metric unit, so we got to convert. So we get 10 kilowatt hours. So 1 kilowatt hour, we look at the conversion from the notes, 1 kilowatt hour is 3,600,000 joules. So we know that the amount of energy that we can buy with $1 is 36 million joules. So this is the amount of work, and it's in the standard units. So now we definitely know the work, and we know that it's in the correct units. So we're going to plug in, and we're going to solve for time. So we know we have 100 watts. We know that we have 3 million, not 3 million. We have 36 million joules, J. And we're looking for T, time. So we rearrange slightly. So we're going to get T is equal to 3,600,000. Nope, almost. 36 million joules over 100 watts. So you're going to get a time of, if we divide these, time of 3,600,000 seconds. So that would be a final answer. That would be the time. So again, let's summarize what this is saying. So if you have a dollar, and electricity costs this much, you can run that 100-watt light bulb for 3,600,000 seconds. 360,000 seconds. So a long time. So $1 will let you run that light bulb a long time. So last thing, again, it doesn't act, this is standard units, so the answer down here is fine. But if we were to convert this in hours by dividing by 3,600, this would be the equivalent of 600. This would be the equivalent of 600 hours. So again, what's boxed is fine, but the hours is a little nicer to look at. So it's saying if we have $1, you can run that light bulb for 600 hours. So with this problem, remember, it looks like there's a lot going on, but it goes back to remembering what the generic power formula is, realizing that kilowatt hours is energy transferred, converting the kilowatt hours to joules, the standard unit, and just plugging in and doing out the algebra. So that's it. That's a good example of a problem. Make sure you have this down, make sure you have the notes down, and that's it for power.